This video is all about discrete random variables. So here's an example of a random variable. The uppercase letter X is used in this case to represent the score when a fair dice is rolled. So obviously the numbers that you may get are 1, 2, 3, 4, 5 or 6, and this is called its sample space. So the sample space for the event of rolling the fair dice is 1, 2, 3, 4, 5, 6. Now a variable is discrete, and that's a technical term, discrete, if it can only take certain numerical values. So there's two words there that are important. It says certain, so it has to be particular numerical values. It can't just be any infinite number of values, and it's got to be numerical. So discrete means there's no in-between values. Sometimes people think that just means whole numbers. It doesn't necessarily mean whole numbers. Here would be an example of a discrete variable. These are the numbers that a discrete variable may take. So it's not just whole numbers, but the point is that there would be it wouldn't be possible to get any number between 3 and 3.5, or 3.5 and 4. Another example could be 2, 2.0001, 2.0002, and 2.0003. This the sample space here is discrete because it's not possible to get 2.00005. You can't get the numbers between those. So that's a discrete variable, and the variable is discrete if you can only take certain and numerical, it has to be numerical values. This one is a bit obvious. The variable is random if the outcome is not known until the experiment is carried out. So it'd be interesting to think of an experiment where you do know the outcome. And if you can think of one of those, then that variable is not random. So a probability distribution fully describes the probability of any outcomes in the sample space. So there are three ways of doing this. The simplest way is simply to write out the sample space. So that's 1, 2, 3, 4, 5, 6, and then to write out what the probabilities are, which in this case they're all equal, so they're all 1/6. So that's one way of writing it. Another way is to draw a diagram. Got 1, 2, 3, 4, 5, 6. 1, 2, 3. Ooh, that's not very good. They're all meant to be equal. So that so it needs to be a bit smaller. That's right. So this is 1/6 here. Another way is to write a probability mass function, where the probability that the random variable uppercase x equals a particular lowercase number, which was called lowercase x, is a sixth. What's this lowercase? Well, x could be 1 or 2 or 3 or 4 or 5 or 6. So you could get the probability distribution given to you in any of these three ways. They all mean the same thing. Maybe the slightly more obscure one is the probability mass function. X can take any numbers 1, 2, 3, 4, 5, 6. The probability that this random variable, uppercase x, equals this particular value, the lowercase x is a particular value, the probability that the random variable equals 1 or 2 or 3 or 4 or 5 or 6 is 1/6. And in the example that we just had, the probabilities were all the same, so the distribution is known as a discrete uniform distribution.